Thanks for coming tonight. Anybody who's new, we're so excited you're here. We can't wait to meet you in the breakout rooms. And all the people who are here often, it's so great to see you again. I was lucky enough to be able to go to my first in-person event the last 2 days, Building Energy Boston. So we were all vaxxed and maxed, but boy, it is so energizing and encouraging to see so many people doing so much amazing work. I think sometimes when we're separated for so long, it's easy to think you're only on your own, but you know, when you see like the wave of other people who are doing things, it's really encouraging. So tonight, I just want to give a toast to getting back to knowing each other, because it's been a while. Cheers. So great. Zach, back to you.
Yeah, thank you, Beth.
I should say, I hope all of you guys can come in person to Boston for the PHN. So if you want to come see some great buildings, come. That'll be, you know, warmer weather in Boston. So hopefully it'll be fun. We have just a really exciting presentation. I know Zach's really excited about it. I'm really excited about it. Jamie Harte is going to be talking tonight, and he's a certified passive house designer with Passive House Institute of Germany. And he worked on his first passive house multi-unit project in Squamish and was the project architect for the one he's going to talk about today, which is on a Canadian campus. And he's also a project architect for Vienna House, which is a project that takes on a number of really complex issues: climate, housing, and creating economic opportunities all in one project. So it's really, thanks Jamie for coming, and we're excited to hear what you have to say.
Okay, I'll just make sure everyone can hear me, and then I'll share screen. Are you guys able to see my screen?
Yes.
Okay. Okay, so I'd like to thank the Passive House Accelerator for the opportunity to speak to you this afternoon. I've learned a lot from these sessions over the last 2 years, so it's really great to have the chance to pass on some of our experiences. And as Beverly mentioned, I'm going to be talking today about a student residence building, which we completed about 18 months ago, back in 2020. So first, a little bit about me. So I'm an architect and a certified passive house designer at Public Architecture and Communication in Vancouver, BC, which, as some of you may know, is the unceded traditional and ancestral territories of the Musqueam, Squamish, and Tsleil-Waututh nations. And so Public is a multidisciplinary practice which combines architecture and communication design. We're a medium-sized outfit with almost 30 people. And as the name implies, we're mainly focused on projects which benefit public life. So whether that be public institutions, public housing, public infrastructure, and so on. So the Skeena Residence, it's a first passive house project for the University of British Columbia. It's located at their Okanagan campus, which is a growing institution in Kelowna. It was also a first passive house project for us as the architects and the contractor as well. It was completed in August 2020 through the early months of the pandemic. And an important thing to note is that the nature of student housing is that completion before the middle of August is absolutely essential. So if you miss that deadline, you essentially miss an entire academic year. So failure to meet the schedule is not really an option. So here's a look at the program, or the brief from the client. So it's for 220 student beds with 110 bathrooms, so bathroom shared for each 2 students. And then we've got study and social lounges on each level, common amenity rooms and storage rooms on the ground floor. That'd be complete for the 2020 to 2021 academic year and built to a passive house standard. So as I mentioned, the project is located in Kelowna, which is about 400 kilometers from Vancouver and about a 5-hour drive. It's in climate zone 5, so it sees bigger temperature swings from winter to summer than we see here on the coast. Kelowna also experiences more regular wildfire smoke. and air quality advisories, which is an increasingly important factor when choosing to build to Passive House standards. The distance also became a challenge during the early months of COVID when air travel was suspended because many of the consultants were located in Vancouver. Thankfully, we'd already engaged a local Passive House designer, Brett Cicello from Nido Design, who was able to provide additional field review support for us during the project. So in red here, you can see the location of the Skeena building, which is in the northwest corner of the campus. It's backing into a forested hillside to the west, which provides some useful shading from the setting sun. The north-south orientation of the building was set by the campus master plan, and the building completes a sweep of student residences facing a large common field for activities. So the form of the building is really a sort of rational response to the program from the client and then the constraints of the BC Building Code. So in this part of the world, light wood framing is generally the most economical method for building a mid-rise residential building, and the code controls the maximum dimensions allowed with combustible construction. So we have a typical floor plan area, which is less than 1,500 square meters, which allows for 44 student bedrooms and the associated social and study spaces on each level. We also have the maximum permitted 6-story height and just under 18 meters to the top floor. By being less than 18 meters, this height also means that the project avoids high-rise building requirements, such as pressurization and venting of the exit stairs, which could complicate Passive House air tightness. It also avoids the need for emergency diesel generators for the elevators. So the adherence to the constraints of the building code and the repetitive programming of the student rooms set us up for a very simplified massing. The challenge after that was to find an architectural expression that could ground the building, ground such a simple building form in its surroundings and express the function of the building in an honest way. So here we can see the north elevation of the building. And for once you can see a hot air balloon in architectural photography that has not been photoshopped in. It's just a happy accident. Many of you will be familiar with the importance of a compact building envelope when it comes to minimizing heat loss and meeting the Passive House standard. Of course, many different building forms can be built to the Passive House standard, but in order to do so affordably, you need to consider the form factor very early in design. We can express this compactness as a surface area ratio, which is the exterior surface area divided by the treated floor area. Roughly speaking, when your result is less than 2, then you're on the right track to affordable Passive House design. So for the Skeena project, our surface area ratio is 1.25, which reflects the simplicity of the massing, although it's a fairly long and narrow form in plan. The only real creases in the form are to create entry canopies at the south and north, and otherwise it's sort of a pure extruded rectangle. In addition to the simple form, there are a number of advantages for Passive House that come with student housing typology in general and with our program specifically. So we've only got 3 exterior doors in the building. We have no requirements for balconies. It's not generally required in this type of project by this type of client. We have no underground parking, so vehicle parking is kind of taken care of elsewhere on the campus. We've got a repetitive unit type, which helps with planning mechanical systems and so on. And then also in our case, the client and the approving authority are one and the same. So the campus was able to facilitate, approvals for a building which is much more simple in its massing than, precedent buildings around it. And then a few challenges for the project. So we've had a very aggressive project schedule with an immovable deadline. The fact that Passive House was a new approach for the contractor. We required relaxation to the primary energy targets for the building, which is pretty common for sort of densely occupied multi-unit housing projects. And then also the pandemic impact, which was a sort of unforeseen and unforeseeable challenge. So our approach to the building structure and assemblies was to, as much as possible, use systems and assemblies that were familiar to trades who work on mid-rise residential buildings in Kelowna. This was in order to ensure competitive tendering of the work and also to guarantee that we could meet the project schedule. So the bones of the building are totally conventional, light wood framing for the walls and wood I-joists for the floors and roof on top of a concrete ground floor. The on-campus location also provided a lot of set-down space for materials, so the framers were able to set up an on-site prefab space and just crane sections of wall into place. Although the project brief from the client firmly committed to the Passive House standard, in reality, the final approval for the project budget from the board of the university and their authorization to construct would come only after tender. And so there was always a maybe small chance that the Passive House element of the project could be removed just before issuing drawings for construction, which could be a major problem for the design team. This was a known risk, so we took steps in design to protect the project schedule as best we could. So if we look at the wall assembly, everything to the left of grid line A is standard wood platform framing, which is then wrapped in a sort of Passive House jacket on the outside. We have 8 inches of exterior rock wool insulation and the cladding supported on a thermally broken clip system. Air tightness is provided by a vapor open membrane on the outside of the structure with a vapor retarding primer on the interior drywall surface. This approach meant that if Passive House was ultimately axed from the project, we could have reduced the exterior insulation thickness as needed without any significant knock-on effects, and the structural framing could have proceeded on schedule. Thankfully, that wasn't necessary. It was also important for the success of the project that there was a single point of responsibility for all the work from the wood sheathing outwards. So that meant a single responsibility for the air barrier, exterior insulation, and finished cladding of the walls. And in this case, that role was performed by TRS Building Envelope in Kelowna, and they were certainly a key part of the success of the project. Here you can see the air barrier in place and windows beginning to be installed. The simple building form meant that the membrane could be continuously rolled down all 5 stories of the wood framing, and it's easy to inspect and repair if any damage occurs or if air leaks are identified. Here we can see the next phase, which is the adding of Cascadia fiberglass clips and steel girts to support the cladding. 8 inches of semi-rigid rock wool is then installed between the clips. And this is our final blower door test, which shows a result of 0.08 air changes per hour, which is a really phenomenal result for a crew working on their first Passive House project. This would make it one of the most airtight buildings in the country, in fact. And I think it's really a testament to the diligence of the trades and the construction manager, which was Sawchuk in Kelowna. The simple air barrier detailing and massing of the building were also a really important factor. So with regard to windows, we used a combination of Westech vinyl windows for the typical residential windows, combined with Schuco curtain wall frames for the larger openings at the ground floor and circulation spaces. Here's our typical window detail, which is fairly conventional. Window frame mounted directly on the wood framing and an interior rod and caulk seal for air tightness. We overlapped the exterior insulation on all sides, including the sill, in order to improve the thermal bridge values around the opening. The sill flashing is sealed to the window frame, and then there's an additional waterproof membrane to deal with any water penetration below this flashing. Here you can see an installed window before the adding of the exterior installation. The opening is surrounded by sections of pressure treated blocking for attaching the jamb and head flashings. This blocking is intermittent with insulation in between to further reduce thermal bridging. And the finished windows look like this. They're fairly far recessed in the opening, which creates some effective fixed shading. And with our cladding design, the intent was to play with this sense of depth and shadow in what's otherwise a very flat wall plane. So we have a primary material of Swiss pearl fiber cement, which projects forward by a couple of inches beyond the dark metal cladding behind. And even with a very simplified smooth massing, there are always exterior components which need to be fastened back to the structure through the exterior insulation. In this image, you can see one of the exterior rainwater leaders on the left, which descends from the roof. and means that we could avoid using internal roof drains and the heat loss and complexity that goes with them. These rainwater leaders are oversized to prevent blockages from any ice buildup and to avoid the need for heat tracing them. Our solution for mounting them back to structure was simply to gang together 3 cladding clips at each floor level and mount a steel T-bracket to the outside of them, so minimal thermal bridging involved. Here's the mechanical room located on the ground floor. The program for the project allowed enough surplus service space on the ground floor to locate the majority of the equipment inside the building. So the roof is free of equipment except for a stub out for a connection to a future potential solar PV system. The mechanical design was by the AME group here in Vancouver. Contains all electric systems, so there's no gas connection to the building. So you can see we've got a centralized ventilation system with 3 Swagon ERVs, one serving the ground floor amenity spaces and the other 2 working kind of in tandem to serve the residential levels. Horizontal distribution through the corridors on each typical level. For space heating and cooling, we've got an air-to-water heat pump, which is connected to Yaga fan coil units in each student suite, with an electric backup for low temperature conditions. The delivery of the air source heat pump was the only really significant element to be disrupted by the pandemic. And in the end, it wasn't installed until about a year after the building was occupied. A temporary system was used for the first year, but the delay did push back our final Passive House certification. And then for domestic hot water, we've got 2 Colmac air-to-water heat pumps and a backup electric resistance heat. There's a common laundry room on the ground floor for the students. At the time, we were unable to source condensing commercial dryers. So these are conventional direct vent models. The damper that you can see on the right opens automatically when the dryers are in use to draw in makeup air from outside. So this heat loss is then captured in the energy model. The damper is then closed when the dryers are not in use. So here's a screen grab of the final energy performance in a PHPP. Heating demand is at 7.4, so it's well under the threshold of 15 for certification. The final blower door test result of 0.08 air changes per hour pulled down the heating demand by more than 4 kilowatt hours per square meter per year. So it has a really big impact on the final results. As I mentioned, there were some delays with the arrival of the final mechanical plant that pushed back our Passive House certification, but this should be closed out in the coming weeks. As part of the construction, the building was fitted with a series of monitors and sensors, which are connected to the building monitoring system. They measure temperature, humidity, CO2, VOCs, and fine particulates, etc. This is part of the university's Campus as a Living Lab program, where the engineering department is studying the indoor environment and energy use of the Skeena building in relation to other student residences on campus. The building spent its first year at 50% occupancy due to the pandemic, but hopefully they can begin to report some initial findings soon. So Skeena Residence was completed on time in spite of the disruption of the pandemic. I think huge credit is due to the contractor, which was Sawchuck Developments, for steering the construction through a challenging time and delivering a project that the campus is very proud of. It was also a great experience for us as the architects, and we're already putting into effect the lessons that we learned on other mid-rise Passive House projects that we're working on. And so with that, I'll hand it back over for questions. Thank you.
Great job, Jamie. And we'll actually head it over to Zach first, and then we'll dive into questions.
All right. Yeah, Jamie, awesome. It's such a great project. So everything we do at the Accelerator comes thanks to support from our sponsors. So I want to give a big thank you to them right now. Our founding sponsors are 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minitair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. Our champion sponsors are Icon Windows and Doors, Proseco, and SIGA, and our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. Thanks also to our patron sponsors, Aero Aggregates, Aero Barrier, Brennan Insulation and Air Tightness, Brooklyn Solar Works, Euroline Windows, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you.
All right, let's dive into the questions. And I know that we also have Patrick Stewart from AME to help out with some mechanical stuff. So Jamie brought some friends in case if he needs to call a friend on some of these questions. The first one is Tom Phillips. The floor is yours, Tom.
Thank you. Thanks for the great presentation. I was really looking forward to it because I saw the news item on the Victoria House, which sounds great. So that I gather is just being completed, but I was wondering, you know, what lessons you've learned, maybe this and other projects about shading and overheating and using future weather data, you know, that you've done for the Victoria House and maybe this project as well.
Yeah, I could just see another question popped up that's kind of similar. So I think, you know, we did use future weather files to do a sort of thermal comfort analysis that Patrick was involved in. Obviously for certification, that's based on the sort of approved retrospective energy models that the PHI has. So I think it's kind of becoming more important to use both. One is for certification, but you can't sort of like half close your eyes to the inaccuracies that are in that. I think it's important to do a proper, you know, 2050 weather file thermal comfort analysis. So Patrick, do you have any comments about the process around that, which was, I guess, kind of slightly parallel to Passive House certification?
Yeah, I do. And UBC is quite progressive in their technical guidelines and actually have some documentation on what should be modeled in terms of resiliency. And so I believe for the Vancouver campus, yeah, they make you model future weather files that they've created themselves as well. So higher peak cooling and higher peak winter weather files. And so that was definitely modeled for us to incorporate to some of our mechanical and architectural designs.
So did that change your design much? Or because, I mean, the general issue is that you might have a really energy efficient building, you know, under current weather conditions and maybe future, but you may not prevent overheating under many conditions. So unless you actually assess it and mitigate it.
Yeah, I mean, I think our kind of simplified approach to, you know, trying to deal with overheating on this project was to go for a lower sort of window to wall ratio than you would see for like market housing. Again, just having kind of a single client that's the owner operator and the focus on Passive House kind of open doors to that. I think the cooling demand is only sort of 2.5 or 3 kilowatt hours, you know, based on obviously the standard look back 20-year sort of weather file. So there's still quite a bit of room in the performance between that and the ceiling of the Passive House standard. So yeah, I think it's generally pretty conservative window to wall ratio. We have very little south facing glazing just by the nature of the orientation of the building. So, and the windows are kind of east and west facing, tall and narrow with very deep reveals. So there's a kind of, they're relatively small in area and they have quite a lot of kind of lateral fixed shading for south facing sun. So beyond that, I don't think, you know, it was tested certainly for thermal comfort, but it didn't, I guess, beyond that change our approach to the design.
You just use ASHRAE 55.
Sorry, we do have active cooling as well. I don't know if that was in the presentation or not.
Did you use ASHRAE 55 thermal comfort or some other overheating guidelines?
So yeah, in the BC building code here, they reference ASHRAE for thermal comfort, and they give you a minimum number of overheating hours. I don't know what those are off the top of my head, but yeah, ASHRAE 55.
Thanks.
Great question, Tom, to kick off the event. Now we're off to Martin, who has two kind of quick ones. So Martin, I'll let you slide in that second one real quick. Martin, over to you.
The second one is, are those windows actually operable? And user behavior is always a big factor. So if you could speak to that. The first question was about the thickness of the wall.
The windows are operable, but they're just operable with the tilt function for ventilation. So then there's a kind of a key override for the campus to do window cleaning and other maintenance. Again, that's something that kind of comes with student housing, that the windows are often on restrictors and just kind of there for ventilation rather than, you know, a window that you can really lean out of. And then in terms of wall thickness, so it's a 2x6 stud with 8 inches of mineral wool on the outside. So we can probably add it up from there. It's probably about
Jamie, just give them the answer in metric.
14 inches, I would say, as a guess. But then the cladding layers are kind of variable depths beyond the insulation. If I knew what it was in metric, I would give it, but I don't.
All right, I'm just teasing you. I think that answered all Martin's questions. So now we're over to, sorry, I got too involved in that question. The next person in the lineup is, sorry, bear with me, long list here, Stephen Endy. I think might have had to jump to another meeting. So Stephen said, was it found to be more cost effective or better thermally to extend the exterior insulation within the sheet metal flashing in front of the window frame rather than installing the window frame outboard of the sheathing and framing to align the IGU with exterior insulated layers? All right, very detailed question. Did you get that, Jamie, or do you want me to
Yeah, I did. So I guess the question is about whether to manipulate the placement of the window within the section detail or just to, so we ended up with a pretty good thermal bridging value. I think it was 0.02 around all sides of the window, which is a pretty good, in the metric figure, pretty good value. And we didn't need to look beyond that. I think the simplicity of just being able to install the window you know, directly on framing in a way that, you know, people are familiar with, and just, you know, screw in the anchor straps. And then again, like a single point of responsibility outside of that for just overlapping the insulation. I think that gave us a number that we were happy with. And it also gave us a kind of fairly familiar, an improved version of a very familiar detail. So it was kind of part of an overall strategy to sort of minimize the number of Passive House innovations that the team had to adapt to.
And Jamie, I'll just interject a question too, is did you guys build a mock-up for that project to be able to look at the window detail? Because on the sides, is it a metal return as well as the top and the bottom?
Yeah. Yeah, so there's a mock-up for that. It's actually some very nice sheet metal work. And yeah, I think there was two mock-ups done. We had a little bit of a change in our thinking about the cladding support during that time. So it was a lot of mock-ups and debate about that.
Is that mock-up still alive somewhere? Because we should get that to the University College down, like either it stays there or bring it down to the one in Penticton.
Yeah, I'm not aware. It might be.
I'll
be somewhere in Kelowna.
Yeah, I'll bug Brett and see where it's hiding. Love a good
Yeah.
mock-up. Okay, sorry everyone. Let's get back to the questions and get rid of my injections. Zoe Kaufman had a question. Zoe.
Hi. Thank you for the presentation. And it went by so quickly that I didn't have a chance to catch the detail of the drains that you were talking about. Would you mind just sharing that one more time?
I can. Oops. Just one moment. Okay, so it's essentially, if you can see my mouse moving around? So there's kind of 3 Cascadia fiberglass clips that are used everywhere on the wall assembly to support the cladding. And then there's a kind of a steel T-bracket, which is outside the insulation layer that's just fastened to all 3 of those clips. And then that's kind of held with a steel strap onto the pipe itself.
Wow. Yeah,
so it's kind of simple. We thought it was going to be some elaborate kind of steel bracketing and, you know, looking at like stainless steel brackets and things, but it was just easier to just use materials that are kind of in use elsewhere in the cladding and just keep it simple.
How many drain pipes were there in total?
Maybe about 6.
Okay.
6 or 7.
Thanks.
And just on that point too, Jamie, did you guys look at originally having those drain lines in the building and then being able to do a thermal bridge of how they affected things, and then decided that they were pretty large and said, hey, we need to pull these out of the thermal envelope to help you out with things?
I think we just decided, it was before my time on the project, it was a very early decision to just slope to one side because, you know, it's a double loaded corridor, but the student rooms are not that big. So the overall depth of the building is not, you know, it's not as big as a normal apartment building where there are, you know, multiple rooms like a bedroom and kitchen depth either side of a corridor. So it's a fairly narrow building, which makes it a bit easier to just slope all the way off to one side and just kind of dodge that issue completely.
Yeah, great detail. 1 second, going back to the queue. Melvin, you're next.
Hi, yeah, just wondering how the laundry room is heated, because I noticed that there's the makeup air. Like, is there any recovery, or is it just the heater in the room?
Yeah, there's 4 hydronic fan coil units that are at the ceiling. I don't believe, Patrick, that there's any heat recovery associated with that. So it's kind of like just trying to do the best you can with one room in particular and isolate it from, you know, ventilation crossovers above it, and just take the hit on the energy model in order to just use some kind of conventional appliances. I don't know if anyone has kind of successfully done a laundry room like that yet and found condensing or heat pump dryers that are kind of, you know, coin fed or with a card or anything. It seems to be a bit of a problem.
Yeah, Melvin, because what did you guys do in the Whistler Passive House?
Similar.
Similar?
Yeah.
I know Scott's in the queue here. Maybe we will ask him on some of his projects he's coming up. So great question, Melvin. Moving along, Michael Scott. Michael, are you still with us? Look up his question. His kind of comment was just about the leaky dryers. So I'm assuming, just again with that space, I mean, you guys did a pretty good job of looking at how to manage the air in that space. But was there any other fine details in that room that you guys had to consider?
Patrick, anything come to mind?
Yeah, when I think of leaky dryers, you think of just the exhaust duct out the side of the building, but we actually went to one kind of header manifold louver connection, and so we had a insulated damper behind that would activate and open anytime the dryers were on, and then obviously close when they weren't being used at night.
Got it. Okay. The next one is Go Google, and she is driving. So the first one was interested in the future weather files part. Do you know where to source them? And someone did make a comment, it's probably in PHP, but again, this kind of comes from the fact that I know some earlier on projects where we had back to the future data. And so future weather data from looking at the 2020 to 2030 and then 2030 to 2050 data in the kind of review to make sure that the 1.5 temperature difference from the 1985 data to current data is kind of included there. So I guess is the PHP updated with future data, or are you pulling it from other Canadian sources?
I don't think the PHP has future weather files associated with it, unless I'm mistaken. And I know this question comes up a lot on multiple projects about sourcing dependable weather files that everybody can kind of agree on, and seems to be not really standardized.
I know I always kind of just default to Monty because he's the one that figured out things with Scott up at the Smithers project, and he's figured out all the right weather data from the 4 different sources that I think he pulls from. So again, at least you had the right Passive House consultant team on it, where you know, they knew to look at which different files. So so that was her first question. The second one I'll just pull up, and then before we get into it, Uh-oh, didn't grab it. So we'll just head over to Jason, and I'll look for that second question that she had. Oh, sorry, I missed a bunch. Sorry, Jason. Hold on a second. Paul is first. So Paul, you're next. And then I'll find the next question that she had. Paul?
Yeah, it was in relation to overheating and just what considerations were given during the design phase about, window size versus shading, because the east and west aspects, I imagine, would collect sun directly in the morning or the evening. Just wondering how that was modeled and thought about.
Yeah, so I wasn't really on the project during sort of early strategy meetings, but I think that we were kind of advised that you've got no control over orientation in the building; it's kind of set. That conservative window to wall ratio would go a long way. Give you a very good starting point.
Yeah.
In that respect, and then I think we've kind of managed to avoid, by the proportions and size of the window, having to add additional projecting shades, eyebrows over windows and so on. So
okay.
I think it's one of those things, like on a first Passive House project, sometimes you just take like conservative assumptions to certain things, certain challenges, and then on future projects, maybe you try to like dig a little bit deeper into questioning, maybe we could do this if we balance it with something else and so on. So it's possible that, we could have allowed a little bit more window area when you look at how much room is in the energy model at the end.
Yeah, thanks.
All right, thanks, Paul. Now over to Scott Kennedy, where I think he wants to steal a detail. I mean, collaborate on a detail. Scott, find that magic mute button.
I'm like a rookie here. Anyways, sorry. I'm actually working on another project as we list here. I'm always interested in the ground level detail, but one of the questions was, when you certified, did you use that new PER program to get higher, like it gives you the higher PER, that new algorithm that's been developed?
Yeah, so we went through most of the project, including well in construction, without that. So just on the kind of soft promises of the PHI that this was kind of, but we had no number to work to. So
right.
I think that's also part of why we were pretty conservative during design about staying well below 50 on the heating demand, in case we needed to sort of borrow space there to keep our PER number down, because we were really fighting. We were never less than 70, I think, on PER, no matter what we were doing. And these types of buildings are full of high plug loads and everything, and really inefficient little bar fridges that all the students have under counter sinks that are brought in. So we dealt with a lot of uncertainty in not having a revised figure all the way through design, which I think knowing that number earlier could have helped us make some more informed decisions. Also knowing how much, obviously big buildings have a big advantage when it comes to air tightness. And, there's a big difference between 0.6 and 0.08. I think it took 4 and a bit points off our heating demand, which, I think maybe if we're working on such a simple big building, again, we might design closer to 15 than we did. So, but yeah, we had a lot of uncertainty about primary energy for months and months and months through construction even.
That kind of matches our experience on our first one, because our first one, I think we overdid the outside wall. And we're using a much lighter outside wall now, but the PER has now become the Achilles heel, right? So, and when we measured the heights, over 50% of the total energy in the building is actually in the common areas. It's nothing relating to the suites at all. It's the parkade, it's all these hallways, ventilation systems. Like, it was surprising. I wasn't expecting that, but that's what turned out, and we're hoping to get better data on the next one. So yeah, the other detail was this, always how these things meet the ground. And it looked to me like there was a detail where you had some kind of a concrete element at the base.
Yeah, there's concrete block that's resting on a corbel below ground, which is, we didn't wrap the foundations we didn't go under the footings with insulation, so we're generally just kind of going down a little bit down the footings, and the corbel is, I don't know, maybe 2 feet below ground. It's just like a cast in place concrete kind of ledge for that blockwork to land on, which was kind of a complicated detail, not the most elegant detail, but thankfully it's all buried, so no one will ever see how it looks. And yeah, we have sort of 2 feet of fairly thin CMU kind of finish blockwork at the base.
So is that CMU designed to go below grade? Like is
we transferred, so it changes to another, it just changes to a cheaper block basically. But I think the same block can go below grade. We just went down far enough to deal with some grade issues, and we transferred to a cheaper, just flat gray block below grade.
It's the ugly details that I want to see.
Yeah, that's why it's not in the set, not in the slide deck.
We never get the ugly ones. We always get the elegant ones. Okay, thanks. That's great. Thanks for your great project.
You know, come on, Scott. We got to have the right ones to present, right? You know, if you want the nerdy, gritty ones, you got to get up to the job sites when they're available. You know that. Great questions, though, Scott. And sorry, Google, you're back, so you can ask your questions, and then Jason, we will get to you next. So we'll turn it over.
Yeah, I am back, so apologies. And thank you for your great presentation. My question was, what are the local codes in Vancouver, and do you have a sense of how much more savings this building got over the local building code?
I don't know. So we have a thing called a step code in British Columbia, which is sort of an incremental improvement towards something that's pretty close to Passive House standard. And each municipality has a certain degree of flexibility on how fast they move up through the steps. And the top step is kind of most of the way to being Passive House, but it's not quite there. So the benchmark, like the sort of price gap between your minimum code building and Passive House gets smaller over time because the floor is kind of rising, like the minimum standards are rising. So equally for energy use, the comparison between doing your minimum code compliant and Passive House gets smaller over time as these kind of standards rise. But I don't know exactly what level of the step code Kelowna was at the time, or what they're at now, because we were kind of exceeding it anyway, so we didn't really have to pay attention to what their minimum standards were.
Yeah, Jamie, they were at step code 1 at the time. And I mean, as of January of this year, everyone in the province is at step code 3. I'm sorry, the other problem too is that there's step 1 to step 3 in residential, but this is multifamily. So it's still step 3 out of 4, which again, it gets confusing. Just everyone go to the higher standards. Just get there. But I think we should all just pause. And I know, Jason, you're ready to ask your questions, but I got to pause because we're about to get to review the plan for the rest of the week here. But I think we all should acknowledge that the fact that you got 0.08 in your tightness, but then of course you had to get bumped up to 1 on the chart. So I know that the Clayton Community Center, I think, got 0.09. So the fact that you're 0.01 below them puts you in a pretty amazing group of people. So let's just raise our glasses and say cheers to amazing air tightness. Cheers, Jamie and the team. Yeah,
definitely. Cheers to the contractors. I didn't put a bit of tape on the building, but they did a lot of hard work.
Well, cheers to them. I know Sawchuck has done a lot of residential houses, and that their ability to scale up to do multifamily. And again, cheers to the air tightness team that took on this challenge and did a great job, because again, it's great for what everyone did there to get that score. Now, again, Jason, I'm going to, you know what, let me ask your questions, and maybe after the overtime, I'll kick off a question. But Jason, over to you.
Thank you, Sean. I just wanted to take a look at the windowsill detail, because over insulating frames has always seemed a bit like a challenge at the windows. How were the sill flashing secured in place in your detail?
I will share it now.
Yeah, this was a great detail. I think everyone needs to screen share this one because this is one that we all should create and redo here with the over insulation?
This is kind of like a cleaned up graphic kind of style detail, but so there's a perforated metal, it's a pretty heavy gauge clip here, which sort of allows ventilation in, and it's folded over to hold down the sill flashing at the outside. So it's actually pretty well like crimped and supported in at the outside edge. And then it tucks the dash line, you can see it's like tucked in behind the jamb flashing all the way back. There's just essentially kind of double-sided tape and sealant at the window frame. So, you know, we had a lot of questions from the trades about this. There is also a secondary membrane down below and drainage mat below the insulation, which you know, in reality, there's going to be some water ingress over time at the back of that sill, and it redirects sort of, it's just kind of flopped over the mineral wool and then adhered to, they put a sealant on the mineral wool and just stick the membrane down on a slope into the rain screen cavity. So there is a kind of secondary drainage plane to get any water that gets through the window sill at the back out beyond the insulation below. So it's, you know, a little bit of a trade-off potentially between, you know, familiar robustness and being able to, you know, over insulate the sills on all of your windows. So not without questioning from the trades, but that was our approach.
No, thanks for the insight.
Supported by the envelope consultant.
Great point, Jamie. We're going to head over to Zach.
All right, thank you. Yeah, thanks, Jamie. I am going to just share a couple of things that are coming up. Also share the fact that on the Passive House podcast right now, we have an interview with Alex Slater of Shared Space Architecture. The co-host of the podcast, Matthew Cutler Welsh, interviews Alex, who is based in Melbourne, and he talks about how he's balancing building science and art in his work, both modeling and designing high-performance buildings. Really, really great conversation, and I think people here will appreciate the kind of geekiness and the kind of his. As I think tomorrow or the next day is the unveiling of the results. So we are sitting on pins and needles, wondering if the Passive House box or the conventional code box will win the challenge, and how much ice will be left in each of those boxes. And so you can go to iceboxchallenge.org and see a live feed of what's going on inside of each of those boxes and get more information about those. Next week on Passive House Accelerator Live, we've got a construction tech edition of the show. And for us in March, we are celebrating Ventilation Month and HRV ERV Month at the Accelerator. So Scott Farbman of DBHMS will be presenting his design insights around ventilating for healthy indoor environments. So please join us on Wednesday. And then the following week, we'll be joined by Sharon Libby of Walsh Construction and Greta Chelvite of Evergreen Certified to present a project showcase edition of the live show about Hobson Place, which is a passive house affordable housing project that is partly an outgrowth of this cool pilot program that the Housing Development Consortium and Seattle City Light and others have been pushing in Seattle, called the Exemplary Buildings Program. So it should be a great presentation, really cool building. It's great to see it happening in my home city. And then we've got some news around Source 2050. And so I think Michael is here and he's going to share a little bit about this event that's coming up.
Thanks, Zach. Appreciate it. And fantastic presentation tonight. Great details. This was a fun one. So for those of you who don't know me, I'm Michael Ingui with Baxtingwe Architects. We do a lot of passive house masonry and retrofits, but we're also doing a whole bunch of other passive house projects now beyond that. Also working with Zach here on the accelerator. And I'm a huge believer in collaboration, and that together we can make a huge difference. It's one of the reasons I enjoyed the accelerator so much, nights like tonight. And it's one of the reasons I'm excited about taking this level of collaboration and aggregation into another realm, which is into the world of building materials and my difficulty in getting them. I, along with John, who's in the chat, who's running Source 2050, will be inviting you to an event on Tuesday night where we're going to discuss all things marketplace. Anybody's welcome. If you've ever had any complaints about what a marketplace should be, what you want out of a marketplace, the hope with Source 2050 is it's one place to purchase everything in one place. So if you're a manufacturer who's interested in being on it, if you have a way you think it should be organized, any opinion at all, it's all welcome. It's a bit of a roundtable discussion, and it's going to be this coming Tuesday night. We'll have a few of them as we develop the site. We want to make sure that we're creating it in a way that is helpful. That's a way that works for you. So hope to see you then, and thanks.
Thank you, Michael, and we'll share this URL in chat in just a moment. So Sean, why don't you take it away?
All right, well, I just added a few more questions that we have going here. So Jamie, hopefully you can continue on with this. But for everyone else, it is the top of the hour. So we know that you may need to leave to go on to other things. The fact that we were able to have you for an hour is great. Thank you for joining us. And Jamie, great presentation. And Zach, thanks again for acknowledging all the sponsors earlier and all the great events we've got going on in the next few weeks. And again, thanks, Mike and John, for working hard with Source 2050. We look forward to seeing where that is at and how we all can help grow that initiative. So great stuff, everybody. So we will get going. But again, just need to acknowledge that if you got to leave, we appreciate you coming. However, you all have homework. You need to bring a friend to the event next week. Again, this thing ain't going to grow by ourselves. We need to get the masses involved. So please continue on. If this was your first night on the accelerator, thank you for joining us. Again, you've got homework. Not only do you need to come back next week, but you need to bring a friend as well. Hopefully you enjoyed this presentation that Jamie put on. And one day, again, if you're ever in the Okanagan doing some wine tasting, definitely go up there to have a look at it. And Jamie, when do you think you'll get that lovely plaque to install?
I heard it's kind of supposed to be this week for the last 4 weeks. So hopefully in the next first half of March would be good.
Next time I'm up there, I know maybe Leighton, we can get Leighton to do a drive-by and take a photo of the plaque, or Brett can pop in there and send us a picture of the plaque. So again, congratulations to a great project. Patrick, thank you for joining us as well. It's always nice to have friends describe things. And again, a huge acknowledgement to the full team for getting an amazing air tightness score. So bravo to everybody. In that list, sorry, I got carried away. Tom had another questions, Mr. Tom Phillips.
Yeah, just standard questions, embodied carbon and wildfire smoke. It looks like, you had maybe local timber, but you have concrete. So, and then wildfire smoke, you got great air stealing, but probably had to beef up the air filtration and so on. So if you could discuss those, that'd be great.
On the wildfire smoke issue, I don't know from an operations point of view what their plan is or how they dealt with wildfire smoke last summer, which they certainly had in Kelowna. So I don't know what filters or what their plan for filtration or boosting the airflow with added filtration is. So I don't know, Patrick, if you're aware of any planning for that.
No, I think you're right, Jamie. They didn't go above and beyond what Passive House recommends for their standard HRVs. In terms of operation, I know they can ramp up and down based on a boost mode, but I don't know if they have any special plans for the extra air filtration on the ERVs.
Yeah, and we don't yet have reporting from the engineering department about indoor air quality during those events. I think that's been a bit, I haven't seen anything yet from them. I know the building hasn't really been fully occupied until this winter. So that would be interesting to see how it's performing, because they're going to get tested kind of most summers probably.
And were you able to reduce your embodied carbon that much?
So, I mean, the university has a kind of wood first policy for and for public funding from the provincial government. We didn't track embodied carbon for any certification or our internal sort of analysis beyond, you know, that we knew we would build it from light wood framing. So, you know, it's something that we're kind of thinking of more and more with projects that we're working on at the moment. So, you know, there are areas around, you know, insulation, for instance, that we've got XPS beneath the slab on grade, whereas certainly when you look at the amount of room in the energy model, I think you could have converted to equal depth of EPS, could have accepted all, you know, industry claims about EPS losing some thermal quality when it gets wet. It doesn't really matter because there's just so much room in there. So there's things like that that certainly we would look at more closely. We will look at more closely on other projects that we're working on. And then equally, I think the concrete ground floor helped resolve. We have kind of a sloping site, so the walkout condition on the north and the south are kind of one story apart. So we had kind of retaining walls on the north of the building. So there's a certain amount of concrete, above grade concrete, that was kind of required by the sort of site profile there. But again, equally, there might have been a mass timber solution to the floor above, or like our initial floor there. So things are kind of changing quickly in that respect. I think every project is looking for mass timber solutions when they fit at the moment, and there's a lot of funding support for them.
Great, thank you.
Yeah, Tom, again, I appreciate that repeat question because again, it's just great for all of us to acknowledge what we're all trying to do. And I think, you know, looking at other projects that RDH is involved with is, you know, that kind of, we kind of laugh a little bit in BC about the RDH wall where it's, you know, wood structure and then rock wall on the outside. And it seems to be that's a little bit of the most cost effective in embodied carbon when you're matching price. However, I know Scott's got a really cool high-rise project where he's doing the Larson Truss on the outside. So maybe Scott, maybe I can just, if you want to just quickly talk about your Whitset project, because I know the embodied carbon is something you looked at and you're having fun with that. So again, I don't want me to put you on the spot and I didn't want to take away, but I know, you know, that's an interesting point of view.
Yeah, I won't say that we did an embodied carbon calculation. We just felt that let's try to use materials that we knew didn't have a lot of problems with embodied carbon. So it actually began a little differently because originally they had a finger joint stud plant on site. So they were making all their own 2x4. So we actually developed it originally as a 2x4 structural frame with a 2x4 Larson truss on the outside with some pieces of plywood. But in the end of the day, over the pandemic, the plant shut down. We didn't have access to the 2x4. So it's now just a 2x4 with a 16-inch I-joist. 2x4 5/8 OSB taped and sealed zero barrier, and then a 16-inch I-joist. And then the roof is, we actually put the 2x6 ceiling joists in, put a deck on top of that and taped and sealed that. And partly that's for safety when they're putting up the trusses. You're not 8 feet in the air or 10 feet in the air. And so they're just putting the roof trusses on it this week in the snow, sometimes minus 30. And so hopefully the trusses will be on. But that one, what we did there is we taped and sealed the horizontal above the 2x6 as the air barrier. And then we're just going to blow in cellulose insulation into the attic. So that's kind of how we did that. Yeah.
Great. Thanks, Scott.
Scott, is it blown cellulose in the Larson truss or in the TGI?
It's specified that way. Yeah.
How many stories is it?
3. It's only 3. It's not a high rise. It's just a 3-story. It's right at the limit of part 9, to tell you the truth, is what it is. Yeah.
Okay.
Yeah.
And yeah, thanks Scott for interjecting with that stuff, because I know Tom, it's you know, again, I know you're asking the questions to make sure that it's all of our minds of what we're trying to do. So thank you for the question. And again, Scott, you know, I'm going to get you to get on here with a presentation for that particular project.
Well, I had a meeting, by the way, with Marcel on the little duplex I'm doing, and he's come back and said Glavel foam glass is the way to go. That would get a few people there. So we're going to look at using that underneath the little duplex, because he thinks that it's actually, even bringing it in from US, is going to be cost effective on the labor side, and obviously got an embodied carbon benefit rather than using EPS. So that was yesterday's conversation. So anyways.
Yeah, now that they're manufacturing locally and they've got some things, and I think there's a few projects where I think Lucio and him are probably going to try to team up and get bigger shipments out for a variety of different projects and have a bit stored here. So
that would be perfect, because it's funny, I emailed them, said, hey, please send me a sample, but I haven't heard anything back. So I just really want a sample of Glavel glass, just so I could show it to my clients.
Scott, I still have a bag. I'll bring it over.
Oh, there we go. That's why we come.
It's an excuse for you to take me out for lunch this time. So
I could do that.
Sorry to take away this. On that point too, sorry, thanks, Tom. You know, again, it's just when we're looking at these different devices, I can interject, Tom, because I'm working on installing a fart shack, and of course it's PH. It's a 108 square foot shed for my dad, and it's using Chris Hill's BOSS program, where he got a grant from BC to look at the thinnest wall, highest R value, most affordable wall, and lowest carbon footprint. And so it's an interesting thing that he's been able to work on. And I, in a sense, created a mock-up for him, but it ends up being the opportunity for my neighborhood and for BC that haven't experienced a passive house to come over and hang out with my dad and get the passive house experience. So there'll be more about that in the upcoming weeks, but it gets shipped from Tag Panels to my dad's backyard tomorrow. So it's going to be fun. So going back up to the queue, because again, we went over those side stories. So again, thanks, Scott, for interjecting. And sorry, the next person is Bruce. Bruce, where are you at? Over to you. And we'll get you to unmute.
Unmute. There you go. Yeah, kudos on designing in the high level construction simplicity that you brought to the project is amazing. I was impressed with the fact that you would have a on-site prefab wall shop going on. In that regard, my question is, were the windows set in a prefab wall and then craned into place?
No, so the windows were installed after all the walls were up. So it's kind of open prefab on the walls. So no insulation in, no membrane on, no windows in, just, you know, kind of standard, what's now kind of standard framing practice, but they just had like a really kind of nice production line set up on site, but they didn't put the windows in before lifting into place. You know, in another time, in another location, it's an ideal project to do, you know, full prefab panelization with windows in, because all the windows are identical. Walls are completely straight, so they can be broken up whatever way is most efficient for a prefab location. But that would have kind of locked us into certainly, you know, a certain system, and probably locked us into kind of something customized for Passive House. And then if we had to kind of take a step back, we would have been in trouble. So we kind of, yeah, pretty simple, minimal amount of prefab, but enough that made sense for the project.
Very elegant details going on in that. Very impressed.
Jamie, there's lots of discussion right now about multifamily passive house projects of how to simplify the manufacturing locally, but the wall system you had could easily be done anywhere and brought into place, and then you just have an issue of stitching. And you know, the joints could have worked really well too, where you've had the downpipes, because you could have done a really cool infill connection right there, and then it gets laid over with the downspout. So fun things to consider as we try to figure out how to scale this and do more at the same time. So going back to the list of questions, sorry everybody, Good. Robert Hall. Robert Hall, sorry.
Yes.
There you are, Robert.
Can you hear me?
Yep.
Hi. Oh gosh, I forgot what my question was. It was something to do with internal heat gain. And you know, it's in Kelowna, so especially in the summer, let's say, how did you, what is the level of, I mean, is it occupied in the summer, I guess, first off, because my question is in the summertime with the added solar loads and all that internal heat gain, how were you able to maintain interior comfort, meaning reducing a number of overheating days?
Well, firstly, it has active cooling, so that sort of switches off your overheating percentage in passive house terms, and then you're just looking at controlling your cooling demand and your cooling load. It is occupied in the summer. The building kind of switches to a kind of hotel style use. I think generally it's not occupied to the same level as it is in the wintertime or the sort of the 3 seasons of the year. So I think it's modeled with a seasonal occupant load, which kind of helps that it's not, you know, considering 220 students in the building for 12 months in the year. I actually think, but I wasn't doing the PHPP modeling, but I think for the academic year, it was kind of modeled on the basis of the same as like a senior's home, that essentially people are in there like more than a typical, spend more time in there than typical multifamily, you know, housing internal load.
Yeah. So I have a bit of I'm just curious because I'm actually starting on a design of a student residence myself. It's further south. It's in California, and I've got an awful internal heat gain, awful heat load, and so the active cooling is actually going to really bump up the primary energy use, and so did you combine like the cooling with the ventilation, or did you have two, or are the systems separate? I think one of your slides
they are separate.
Yeah.
They are separate. I think a project we're working on now, which is in Vancouver and out on the coast, we're looking to combine. So it's kind of like pre-cooling of the ventilation area. But in Kelowna, it was separate systems. So there's a fan coil unit in the ceiling of every student room with individual thermostat control. It's quite an extensive, like not the most cost-effective solution, but it gives, you know, a huge amount of control throughout the building, simultaneous heating and cooling and different things, which maybe in hindsight might not be required in passive house with less temperature swing from location to location. But yeah, they're separate. So the ventilation system and the cooling are two. One is the hydronic and the other is just the piped, the ducted air from the ERV.
Okay. All right. So, and you still can meet the, obviously you've still met the passive house primary energy.
Yeah. So we have a pretty low, we have a low cooling demand, which actually doesn't really contribute that much to the primary energy. It is fairly hot in Kelowna. It's, from my perspective, it's very hot in Kelowna in the summer, but I can't really say what measures made the difference other than sort of building orientation and conservative window to wall area. And then I guess trying to drill into your seasonal occupancy modeling, if there are times in the year where it's not occupied as much, that you try to capture, especially if it's an existing campus and all of the other buildings have a certain occupancy pattern that you can depend on, and then you can kind of model that.
Yeah, that's a good point. Yeah.
So
if you don't mind me jumping in a second, so, Robert, in terms of the cooling, the ventilation air, we're seeing that working. There's some residences up in Pemberton here, which is a similar sort of heat in terms of Kelowna cooling ventilation air. It's working. Our University of Victoria student res, we're doing that with cooling of ventilation air. So the cooling of the ventilation air, if you're conservative with the windows, you know, is I think is the best and most cost-effective solution. But I think it's, you know, when you start to get into condo buildings, trying to convince people to put the kind of windows that you put into into student res, maybe doesn't work as well. So that's where either you gotta get much more aggressive with your active shading or overhangs to make that cooling work with the ventilation there.
Okay, no, I think that's okay. I think the preliminary drawings have a similar shaped windows to what Jamie was showing. So, wall, window to wall ratio. So that'll probably be, we can accommodate that. Yeah, thanks a lot, Jamie.
Sure.
Hey, Jamie, on that point too is, what was the model like when you were at 0.6 air change? What were some of the other energy requirements? And then how much was the difference? I think you might have mentioned it, but how much was the difference between when you went from 0.6 to 0.1 in the energy model?
I think it was like 4.2. So the air tightness made a massive difference because it's so low, the air leakage in it, that just the difference between what you're modeling and what you're getting is what you're modeling through design and what you're getting in the end, which is not something that you could really, bank on. Like no contractor is going to sign up to saying, actually, you have to hit 0.2 in order for us to save money elsewhere in the project. So, yeah, I don't know if other people like Scott, if you're finding on other like multifamily projects, if first of all, if there are other ways that you're supplementing your testing using other methods than just the I can't remember what they call it, N50 or whatever. And also if you're banking on a lower number because you've got a big volume with a small outside skin, or if you just always design to 0.6 and you can't trust getting anything lower than that.
We've been designing to 0.6. We had one that had trouble hitting it. Generally, we've been trying to, well, we've had a couple at right at 0.6. Okay. But they're not we haven't done them with the ease of an exterior insulated wall. So we've done a lot of stuff that isn't an exterior insulated wall. Now we're doing some stuff now that is. And part of that was just cost. Like we were dealing with contractors and they didn't want to build that wall, thought it was cheaper to do other things. So, the details get more complicated. In some ways that's nice and clean with the outside walls. You have a very simple form, so all those are good things. But remember, we're building in Vancouver where we got wedding cakes and all these other problems to deal with. And one of the things we're looking at doing now is every time they give us a wedding cake, we're going to make the floor maybe 16 inches thick because you've got these walkout balconies and you just can't get enough insulation on them. So those are all things that we're working on to try to figure out how to do that. But the good thing is we're getting away from wedding cakes again. So that's the good thing. Everybody's understanding simple shapes is the key to construction costs.
Definitely.
Yeah.
Shannon's
wondering. Did you guys do an interim air tightness test, by the way? Did you try an interim one?
On this project, on Skeena?
Yeah.
Yeah. So because the stairs are at the kind of opposite ends, they were able to isolate just inside the end stairs. I think they tested the top 2 stories because they kind of everything was done from the top down. So windows in and then go down the building, drywall in and then go down. So they did test and do like exterior thermal imaging as well as air tightness testing on the top 2 levels when the gypcrete was on and the floors were kind of isolated from the levels below and just sort of sealed them at the ends of the hallways.
Yeah, that's so hard. If you do CLT, that's quite easy, but when you have a hollow floor, there's so many air paths. It's impossible to get a result that you can count on. So we're pretty much saying, we're just going to rely on workmanship, and our key is educating the site super, at least the site super, but preferably at least 2 people on site need to take Sean's trades training course, or somebody's trades training course, or Passive House Canada's, or BCIT's, or any trades training course. It makes such a huge difference. It's so nice to get a phone call from a site that says, I think we got a discontinuation in the air barrier. How are we going to solve it? Or, hey, I think you got a thermal bridge here that we missed. It's just enlightening and so nice to have that happen. So that's a key for me.
Yeah, I know that Sawchuck had a couple other individuals there, and they've actually requested like their entire office get tradesperson training. So it's exciting to see that they've got on board. And in a lot of cases, I know like Clayton Community Center that had another great score. They had the site super and every super of the major trades take the tradesperson course. And so it was great that HMA enforced that in their specifications, that if you got the job, you had to make sure you budgeted to get the training. So, and I mean, I know that Brett was there a lot, and there was a lot of eyes on that particular project, even from RDH. So but to get the number you did is, again, a great acknowledgement to the team, and you know, glad that it helps out so much when into the PHP models, which it's great.
Hi, Sean. Can I say my comment now? It's
go for it. Yeah, sure. Good time.
Thank you. It's kind of built up as well. I wanted to say for the air tightness team for the project as well, very good job. And I have to say that the team, although you didn't lay one piece of blue skin yourself in the project, but it really starts with the designers. Because in many other cases where we have brand new buildings built here, and the contractors will be blamed that the air tightness is miserable if it's not a Passive House project, they will blame it back on the design team. So, well, you didn't show me that detail, and you probably made a detail which doesn't work. So it starts really with a set of eyes, not diminishing any of the contractor's responsibilities, but it starts there and it continues with the good workmanship and review and so on. Secondly, where it kind of went into two directions. The first thing I say, well, the project has been started in 2020, and I'm glad to say in this case that now that you mentioned that you had the Shuku curtain wall, so you brought it from overseas. Now there is a North American aluminum unitized curtain wall. It's the first one in the world. It's designed in Canada, and it's on the components website of the Passive House Institute. And it's been built in New York and tested in Pennsylvania, passed the test March of 2021, and it's ready for next North American project. Third, built up in the comments. What we were fighting here, I was the president of the Ontario Building Envelope Council, that's in Toronto, Canada, or Ontario, Canada, for 2 years, and we've been fighting the government to include air tightness in the building code. And there was always something which came to distract and defer the importance of the air tightness in the building as one of the major, if not the major, factor of energy saving, carbon and comfort, and so on in the building. And they came up distracting, so, well, it's the glass. If you have too much glass, so let's make it 40, 60%. And they started to put crazy, unreasonable, excuse my language, but it's unreasonable number. What does 40, 60 means if the code does not have any line or any restriction for thermal bridging? So the 60% opaque wall can have 90% thermal bridging, and it would be functioning as of 10% of the insulation value which is in it. If it's 8-inch or 10-inch of insulation, you get the value of 1 inch of those because it's full of thermal bridging, and the code allows it. And now, where am I taking this? I'm taking this actually to the new distracting point which is coming up on the market. Instead of people thinking, well, let's take all the factors of, and saying factors, the curtain wall is called factor 2, by the way, but seeing the factors of the importance of all the components of Passive House to get the building right. And the new distraction point is the embodied carbon. So again, it's going to come in and people are going to focus more on the embodied carbon and going to neglect and fight the air tightness from being included in the code. And when I say the code, in this case, I'm saying that about Ontario. I know in BC, it's in the step code and it's to a certain level getting included. So I really appreciate them for doing that. I'm fighting my battle in my province first.
Well, you're lucky because again, we're all working hard to fight this battle. And again, I mean, in City of Vancouver, they're now getting buildings to look at the embodied carbon. And when Tom shows up every night and asks us to be aware of the carbon calculation, it's great. And usually we have Harvey coming to talk about price. So again, if we continue these conversations and questions, we will all be able to keep fighting the battle. But you definitely have some interesting projects in the Toronto neighborhood that are working on passive houses and the mass timber. So it's we're making headway. So keep up the fight, and you know that you've got a community here that supports you.
All right, don't get distracted from the main factors that gets you a good building. Focus, yes, include embodied carbon, but do not neglect and get distracted off the way. Thank you.
No, you're right. Air tightness is the easy mechanical system to install. That's for sure. Now, Andrew, did we leave over? I think Andrew left us. Uh-oh. Just 1 second. Let me see who's still here in our list. Ash, you had a question. Yeah. There you are, Ash. Go ahead. If you go ahead and ask your question, Ash. For some reason, we can't hear you, Ash. So I don't know if you want to pull out your earbuds and try without, or I can ask your question because I did capture it. Jamie, Ash was wondering the air tightness again is the PHI standard, and wasn't sure if you had looked at FIAS. Again, I know you guys strictly are PHI certified, but wondering if you had considered any of the FIAS numbers, or if anyone asked you to how this building would perform under the FIAS methodology.
Well, I don't actually know what FIAS uses as a unit for. I'm sure it's still air changes per hour, but is the pressurization different?
See, Jamie,
has anybody done projects in both?
This is where we default to Kevin Brendan, and he would come in and be able to tell us the conversion of it all. But no, we do have some people, like I know in Toronto, they've done, I mean, Indwell has done projects where they've done FIAS and PHI and looked at the differences in different certifications. But I know for you guys, and Ash, just to kind of summarize that, is this particular project was focused on PHI entirely and didn't look at, the FIAS one. But hopefully that answers your question. No, we can't hear you, my friend. It's okay. Hopefully that answered. You can just keep chiming into the chat and I can interpret that. Eric, I see Eric is still here. Eric, did you want to ask your question?
Yeah, sure.
There we go. And then I think we're about it for questions. I'll double check, but.
Okay, yeah, I think a construction photo caught my eye because there seemed to be a large metal duct running to ground on the end of the building with a connection at each floor. And I was wondering what that was all about.
Yeah, so that's just a temporary heating for construction. So I don't know what the unit is. It sits on the ground, but it's basically just, I think it was at both ends of the building, just ducted up and sent in through an opening at the end of the corridor on every level. So I'm sure that wasn't really needed once all the insulation was on, but they were building through the winter. So that's just kind of temporary construction heat.
I was guessing that. How did you deal with dust? Or drying out? Are those issues that need to be dealt with during construction too?
I mean, drying out would be only a good thing, I would think, to try and, dry out the construction moisture before you sort of trap anything in there too tightly. So I'm not sure. I think it's on not on like a huge flow rate, and I'm sure it got sort of dialed down once I went in once the windows were in on most levels, and it was getting pretty warm in there, even in the winter time. So I think it wasn't in there for too long.
Thanks.
Thanks, Eric. And Victoria, if you're still with us, I see that you have a question that I didn't properly gather, but Victoria, you want to go ahead?
Yeah, I was curious because you mentioned you based your energy modeling off of senior homes rather than multifamily housing for how much expected energy you were supposed to be able to generate in the building. And I guess this was kind of also building off of the overheating question that is it Robert that said that? Yeah, Robert Hall said. And I was just wondering, college students, I would assume as one myself, that we use probably a lot more energy single person than by person than seniors do, especially with just all the electronics everybody tends to own. And then again, also how that fits in with the high performance computers that a lot of college students use. Like I have several friends that have like gaming PCs that whenever I visit their dorms, it's always extremely warm in there, and we are not passive house dorms at all. So I'm just wondering what you guys have done to account for things like that. And then also mini fridges and other appliances that would be in every single dorm room.
Yeah, so those are generally kind of captured, all those plug loads are captured under the electricity tab, I think, in the PHPP. So I think when things are known, like we knew for sure that they generally have really inefficient like under counter sinks, and that there's always computers plugged in at a minimum charging, like those are kind of factored in. I doubt that it gets to the nuance of breaking down sort of power consumption by, having like high powered computers that have like a big fan draw and things like that. So I would guess, I didn't do the PHPP modeling on this, but I would guess that it's like a fairly simplistic, just, computer plug loads applied. And I doubt that it's, I think that nuance of, more powerful gaming computers I doubt that that's captured. And then separately, there's the kind of internal heat gains of just the occupancy hours of the building. And that I think is what's modified to be kind of more similar to sort of seniors housing, just to capture the fact that people are spending like a lot of time in the building. So that's kind of captured in the front end of the PHPP, and then all the plug loads are kind of in towards the back. But it's a good question about exactly how much detail you put into that and how much certainty you have about it.
I guess how though would you address that overheating though, because of the computers? Because I know that in dorm rooms that aren't passive house, that those rooms get really hot and stay warm, and there's no air conditioning in the dorms here. I'm in California.
Yep.
So I was just wondering, I guess you mentioned that there is air conditioning, but is all the cooling then active cooling? There's no, I guess, passive way to draw that out in these buildings?
No, I mean, there's a little bit of free cooling that you get through the ventilation system, so that, it can run just on a bypass mode in the when there's cool nighttime conditions and you're exhausting quite warm air, rather than exchange that, so you're going to get warm incoming air. It just takes the cooler incoming air and just you get free cooling without heat exchange. When you don't want the heat exchange, you just want to dump the heat from the building. So there's a little bit of free cooling that you get on the ventilation system, but then the active cooling, which is all the kind of ceiling fan coil units, that's what which are connected to a heat pump. So that's kind of what kicks in for, guaranteeing thermal comfort. So, and there's openable windows, but being realistic, the amount of cooling you're going to get through natural ventilation through quite a small window opening is probably quite modest.
Thank you so much.
Hey, Victoria, thanks for joining us. Because again, it's always, you could be our insider to figure out how many students are using their dorm rooms for Bitcoin mining, gaming, and also be the source
More
of
than
like,
you'd think.
how, pardon?
More than you'd think.
I know, that's why I brought it up. And
yeah, because dorms, you just pay a flat rate for your housing, so nobody has to worry about how much they're paying in utilities. So I do know people that I think one of the UCs actually formally like banned mining, like you're not allowed to do it. But unfortunately, and yeah, Tom brought up how fridges were not allowed in the dorms there, but there's a lot that students will bring in that they're not exactly supposed to bring in. And that's anything from mini fridges, which are allowed at our dorms here, but some people would bring toaster ovens and kettles, like electric kettles and stuff. So there's it's kind of difficult to regulate students as far as what I've seen from my peers.
Yeah, it's insightful. I mean, I think the data monitors that they have installed will provide some great insights. I know, again, going to one of our really interesting projects was the Monty Showcase, the Bella Bella Passive House project. And there's one unit where they couldn't figure out why the energy was so high. And of course, that was a gentleman that was riding his bike. And so he dumped a lot of humidity and heat into the space because he had 3 giant screens that he was racing against. So it's interesting to have these insights. So thanks, Victoria, for always joining us and the questions. And I'm sure the data that will be collected from UBC Skeena will be valuable for future projects to figure out, again, the plug loads and the extra heating that students are dumping into their spaces. So, well, I think we got through all the questions. Tom, I know you had a couple of comments. I don't know if you had any other questions. He might have carried on because, again, we're a little further into here. So I think we're wrapped up for questions. Jamie, anyone else have anything else to put in? Any other insights? Stuart, you got any other crazy Passive House projects you're working on that we'll soon get you to present on soon enough?
Just the Vienna House project that we're doing with Jamie. I think that one's going to be cool. It's courtyard scheme and a lot of that work going on in natural ventilation and that passive cooling. So that should be a good one.
Yeah, you guys are always up to great stuff. So I know it's Jamie, thanks for putting in that ZebX chat. And for everyone else, if you're still with us, save the chat. You just go to to your name bar over on the far right. There's 3 little dots. I haven't done it yet. So just click on it and save the chat so you can get all the great links. One thing that Jamie, just interesting insight is, the West Tech Windows were a local window manufacturer. Have you thought or even asked them? Because I know some of the European windows have it where the metal sill flashing actually rides and gets installed underneath. I mean, that would easily take away from that kind of weird caulking double-sided tape issue that we've seen in many projects. I think we even have a couple of examples at BCIT's lab of modified windows. But is that any R&D that you guys provide to them for them to maybe go back and figure out a solution for future Passive House projects?
We haven't, but I've can see that on like all the aluminum clad wood windows that you get in Europe. You can generally feed the because they don't mind to modify the profile, obviously, because it's kind of supplementary. So it would be great to be able to just like tuck it in there and say that's it, it's in and it's going to stay there, and then you can over insulate if you want beneath it. But we have not really talked to them about it. It's something that I look for. It's kind of on the wish list for Windows, but there's lots of wish list items.
Well, I know, the Veta windows and OptiWin have it. I know Innotech has created a window where they've got a raised profile, so you can slide underneath their UPVC window system. So that's pretty cool. So again, it's just great to highlight our wish lists of things we want from the community and suppliers to improve on. So again, thanks to suppliers for showing up. Thank you for sponsoring the accelerator. We appreciate all the insights, and it's great that we do have a bunch of window manufacturers as sponsors. So we are lucky. Otherwise, everyone, Jamie, last cheers for you, my friend. Thank you for coming on. I know, so cheers to you. I know Passive House Canada has got you on the next local Vancouver Pulse for, I think, the month of March. So hopefully we'll continue to hear this story and other things you're working on. And again, great insights here, great delivery in the presentation. And I'm sure, have you guys had like a team wrap up party at all to congratulate everyone, or is it all just an online event?
Yeah, I mean, it all got finished kind of quickly, and it was all during COVID. So I haven't been to the building for a long time to see it, in its kind of finished state. So yeah, it's like anything during any major milestones during COVID is a slightly underwhelming experience, but I'm sure we'll get together sometime soon.
Well, it's definitely on my bucket list too. The next time I'm in Kelowna to pop by, and it's actually funny. I think I've driven by it 3 or 4 times, and of course, I was racing from one project to another, but I definitely saw it on the hillside. So, again, great to have this. Great for UBC to have a Passive House project. I know there's definitely more here at the UBC campus here in Vancouver that they're working on, and again, great to have that under your belt. So, thank you for joining us, Jamie. Great presentation. I can see more praises through it, and glad that Michaela was able to join in on it as well. So great stuff.
Yep.
All right, everybody. We're going to wrap things up. So on the docket, you have Friday. You can hang out with Mark and Dave, and we've got our host, Bev, who will be hanging out with Mark and Dave on Friday. Tomorrow, you might see some Instagram videos of the Fart Shack being installed in Maple Ridge. It's a joint venture between Tag Panels, who constructed the Boss system from Beat Collective. We've got some Intertech windows there. It's going to happen on my dad's backyard, which is pretty exciting. And then a fun week of events next week. So I think we can say goodnight, everybody. Thanks, Jamie. Appreciate everyone showing up.
Thanks, everyone.